Now we're going to look at another method of solving some first-order differential equations, which is known as the integrating factor method. It comes out as a consequence of the product rule. So we're going to just start off by looking at differential equations which have come from differentiating a product of two functions. Okay. So this example one here, we've got on the left-hand side, we've got x cubed dy by dx plus y squared, 3x squared y. What you notice here is that if you differentiate x cubed, you get 3x squared, and if you differentiate y, you get dy by dx. This has come from the product rule, so if we had our u to be x cubed, our du by dx would be 3x squared, and if we had our v to be y, our dv by dx would have been dy by dx. So this left-hand side has come out because of the product rule. That means we can rewrite this left-hand side as d by dx of the product of y and x cubed. Right, so x cubed y. So those are our u and v functions. This is equal to cos x. Now all we've got to do to solve this is integrate both sides. Integrating the left-hand side, we just get rid of the d by dx. Integrating the right-hand side goes to sin x and plus c. The question asks for it in the form y equals f of x, so I'm going to divide through by x squared. It's sin x plus c over x cubed. The plus c must be on the top of the fraction, it can't just be on the end here because it's being divided by a variable rather than just a number. So pause the video, have a go at this U-try question. We can extend this idea to solve other differential equations which have dy by dx in and just y, not if it's y squared or anything like that. Well, sometimes, but if you can get it into the form dy by dx plus y times a function of x, you can then apply this integrating factor method. The integrating factor is found by doing e to the integral of the function that's times by y, and then you multiply the whole differential equation through by that, and it will turn it into the form as the same as the one that we've just been doing. So in this one, the function times by y is 2 over x. So my integrating factor for this one is e to the integral of 2 over x. Integrating 2 over x gives me 2 ln x. No need for a plus c in this power of e. I can write this as ln x squared, and then the e and the ln cancel out and just give you x squared. This is my integrating factor that I multiply everything through by, so I'll get x squared dy by dx plus 2xy equals x to the 4 minus 3x squared. I've got to multiply the right-hand side through by x squared as well. What you now recognise is that the left-hand side came as the consequence of differentiating the product of x squared and y, because the 2x came from differentiating x squared and the dy by dx came from differentiating y. I can now integrate both sides to solve this. So my left-hand side becomes x squared y. Integrating my right-hand side, I add 1 to the power and divide by the new power with a plus c on here. And finally, I'm going to divide through by x squared, which will be x cubed minus x plus c over x squared. Again, pause the video and have a go at the U-try. Again, this is one that we can integrate using an integrating factor because it's dy by dx and y times a function of x. This time my integrating factor is found by doing e to the integral of minus 3x squared. I need to include that minus in there. And integrating this will give me e to the minus x cubed. This doesn't simplify, so this is my integrating factor that I'm going to multiply everything through by. So e to the minus x cubed dy by dx. Minus 3x squared e to the minus x cubed y. And I've got to multiply the right hand side through by e to the minus x cubed as well, which will cancel with the e to the x cubed that's already there and just give you x. The left hand side I can write as a product of e to the minus x cubed and y. and the right hand side is just x. Integrating this gives me e to the minus x cubed y on the left hand side. Integrating the right hand side gives me a half x squared plus c. In the question it tells me that when y is 1, x is 0, so I can sub these in to find the particular solution. So I get e to the 0 times 1 plus a half times 0 plus c. This gives me that c equals 1. And finally, if I times through by e to the x cubed, I can get y equals half x squared e to the x cubed. And then c times e to the x cubed just gives me e to the x cubed. So you could have the e to the x cubed factorized. Again, pause the video and work through this u try. Now the ones that we've done so far have been in the form that we've wanted them to be in. They've been dy by dx on its own and y times a function of x. Sometimes it won't always be like that, but you may be able to rearrange it to get into that form. For example, this one here, the dy by dx isn't on its own. So the first step I've got to do is divide through and divide everything through by that x plus 2 bracket. So the 2y needs divided by x plus 2 and also the 5 on the right hand side. This is then an integrating factor question because it's dy by dx on its own and just y times the function of x. That function is minus 2 over x plus 2. You've got to include the minus here, which will integrate to minus ln minus 2 ln x plus 2. We've got to take that minus 2 off, and then the e and the ln will cancel. So this gives me x plus 2 to the minus 2. And I could just get rid of this modular sign here once I've taken it out of the e. This is my integrating factor that I'm going to times everything through by. So I have x plus 2 to the minus 2 dy by dx. Now x plus 2 to the minus 2 times 2 over x plus 2. Well, 2 over x plus 2 is the same as 2x plus 2 to the minus 1. So x plus 2 to the minus 2 times x plus 2 to the minus 1. If I add those powers, I get minus 2x plus 2 to the minus 3 times y. And again, on the right hand side, that's 5x plus 2 to the minus 3. We'll just jot that in for you just to make it clear. 2 over x plus 2 times x plus 2 to the minus 2. That's the same as 2x plus 2 to the minus 1 times x plus 2 to the minus 2. And if I add those powers together, x plus 2 to the minus 3. The left-hand side I can now write as the differential of a product, so it's of x plus 2 to the minus 2 times y. The right-hand side stays as this. And now I can integrate to solve this. So x plus 2 minus 2y equals integrating this. So I add 1 to the power and divide by the new power on the bracket. There's no number in front of the x, so nothing else to divide by, and I've got plus c. Question asks for the general solution. It asks for it in the form y equals f of x, though, so if I times through by x plus 2 squared, I get minus 5 over 2 plus c x plus 2 squared. Pause the video, have a go at the final question for you. All of the answers to these questions for you can be found in the completed version of the pack on SharePoint.